He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Kia ora, nau mai haramai ki te ao hurehinga. Hello and welcome to Our Changing World, ko Claire Kincannon tēnei. This week, what do earthquake engineering and screening for breast cancer have in common? According to the Cancer Society, there are more than 3,000 breast cancer diagnoses in New Zealand each year. Eligible women between 45 and 69 can get free mammograms, but younger women have to decide whether to fund the test themselves. So, engineers in Christchurch, looking at how buildings move in a quake, are now applying some of that thinking to the analysis of breast tissue. They'd like to develop a low-cost device that will let more women screen for breast cancer more often. Katy Gosset visits the University of Canterbury to meet the team behind this new approach.
This is a group of Christchurch women, all in their early 50s. They've been friends a long time, and amongst all the laughter and the catching up on work and family and children and everything else, there is also, at this age and stage, talk of health issues. And sometimes this.
I get told to suck my tummy in.
And then hold your breath and don't breathe.
I'm much more efficient at it now though, because I go every year for a mammogram, and in the last 5 or 6 years I'm in and out so much more quickly.
So just now they're talking about mammograms. In fairness, because I asked them about it.
I mean, if you had to survey people, most people don't like their mammograms. But we're of a demographic that goes.
And there's a good reason for that.
I'm at high risk because my mum died of breast cancer at 66 and I've had a lump removed from my breast.
New Zealand has a breast screening program that enables women aged 45 to 69 to get a free mammogram every 2 years.
I'm still only funded for every 2 years, but I just feel like it's such a high risk area that I'd rather pay and go and have it done every year.
Figures from the Cancer Society show that each year more than 3,000 women and a small number of men are diagnosed with breast cancer.
Having no idea that I had breast cancer until I turned up and had my very first mammogram, I would say I would go and have one every week. It's just a no-brainer. It's an absolute no-brainer.
Did you think about having a mammogram earlier?
No, well, I had no reason to. It was literally my first one that picked it up. It's 46.
So what if there was an earlier opportunity to catch breast cancer? With that in mind, I've come to UC, the University of Canterbury, to meet someone who's working on just such a device.
Hello, hello. Nice to meet you, Jessie.
Jessie is Dr. Jessica Fitzjohn.
And I've been working on this project for about 5 years. So, I did my PhD, kind of like designing the diagnostic algorithms and stuff for it. And before that, I did my undergrad at UC as well.
Her background is in mechanical engineering.
I was just definitely really keen to get into this project specifically. Use my kind of engineering skills to help develop it, basically. I know that a lot of women, don't really like going to get a mammogram. It's not the most comfortable experience, and there's a bit of an access issue in New Zealand.
We'll come back to the comfort factor and that access issue in a bit.
I just thought that, this sounded like a no-brainer in terms of, technology that could make a big impact, and I was excited to get on board and see if I could make a difference and help develop it, which we've been able to do over the last few years. We've made some big breakthroughs, which has been really cool and exciting to see it develop.
So if you're coming up with some kind of machine that can test for breast cancer, probably, using earthquake engineering wouldn't be the first thing you'd think of.
So if we think about when you're looking at the motion of buildings, you can kind of identify the underlying ground tissue properties, right? So by looking at those vibrations, you can know what the soil properties are underneath.
So what if you could apply that same concept to breast tissue?
So basically, we just apply a small vibration, so it's like plus or minus a couple of millimetres, to the breast. So the woman lies prone and the nipple sits on this small vibrating thing that we call an actuator, moves up and down a couple of millimetres. We take photos of that surface motion as it vibrates, and then we're basically using the analysis of that surface motion to figure out what some of the underlying tissue properties are. And then we know that cancerous tissue is 4 to 10 times stiffer than healthy tissue. So if we can find some of those inconsistencies and some of those regions of high stiffness, then we can use that to diagnose cancer. So it's quite a simplified concept, I guess, and it's been used before a lot in earthquake engineering, but we're just applying it. So it's no radiation, no compression or anything needed, it's literally just vibrations and analysing the surface motion of the breast as it vibrates.
So that basic premise that how a surface vibrates is affected by what's underneath it was very evident here in Canterbury after the series of earthquakes in 2010 and 2011. Buildings responded very differently, and we all became familiar with the term liquefaction.
Some buildings were pretty stable, and some, obviously, places that had liquefaction and stuff, they were a lot more harder hit. So it depended on the underlying ground properties. And we're using the same concept of analysing that surface motion vibration on the breast and using that to infer what some of the underlying tissue properties are. We have cameras that kind of take photos, take images of that. Then we have image processing algorithms which turn those photos into thousands of data points. We have over 14,000 data points on each breast and tracking how each of those points vibrate, and then we're kind of analysing those vibrations to figure out if it's consistent among the breast or if there's any big discrepancies which could indicate a cancer.
So let's get up close and personal with the device, which at first glance is an unassuming pair of black boxes. Well, I should get you to talk me through how it all works. I mean, I can see now, what is that, 2.5 metres long, maybe, and a bit over a metre wide?
Yeah, about 2.5 metres long. It's kind of in two sections, so there's one black box, about 1 metre by 1 metre, which is the machine itself, and then there's just another foam piece which we've used just for the woman to have a more comfortable lie on that's kind of tapered down. And so basically what happens is the woman will lie on this whole structure. One breast will go in this hole here. Then this little white thing that you can see, basically it's just a small circle shape and it's called an actuator. So the nipple will kind of rest on that. That will then move up to a certain preload and then vibrate up and down, plus or minus a couple of millimetres. There's then, at the moment, there's 5 surrounding cameras. We're wanting to upgrade that into 7 cameras to basically get more overlap and a little bit better data in some of the inconsistent spots. And there's also strobe lights that are used. So the strobe lights basically flash at the correct times depending on what frequency of vibration we're using, and they can basically so help to capture the image at different periods of the vibration. And then basically the rest is all done by an algorithm after that. The algorithm will take those images, convert them into the thousands of data points on each breast surface, and then my diagnostic algorithms will use that data and basically infer a diagnostic outcome.
Of course, the burning question is, does it work? Is it accurate? Jessica's team has already run a clinical trial with the help of Canterbury Breast Care.
So basically, a woman who'd been diagnosed with cancer, they'd kind of decide whether or not it was appropriate to ask them to be in the clinical trial. Everyone who was asked said yes and was really keen and happy to help out. So the data we're kind of working with at the moment is we've got 28 breasts and 13 of those have cancer. One of them was actually a false positive with mammography that we diagnosed correctly. And we're getting kind of accuracy around, so we're getting sensitivity 92 to 100%. Sensitivity is saying that a woman has cancer when they do have cancer, and specificity 80 to 86%. Specificity is how well the algorithms can say that a healthy woman is healthy. So we're hoping that that specificity value that's a little bit lower than what we'd like is going to go up with improved camera technology, which has come a long way since we did the first trial and since we made the first prototype.
At the moment, the team is checking the accuracy of their tests against the women's mammograms, although ultimately Jessica would also like to be able to compare their results with an MRI as part of a larger clinical trial. But for the moment, they are already detecting small tumours.
So the smallest we had 2 tumours down at 7 millimetres, and we could diagnose both of those.
That's roughly the diameter of a small peanut.
So on average, mammography diagnoses between 12 and 14 millimetres. So yeah, we were looking at pretty small tumours, but that was obviously for the clinical trial, we were just taking whatever patients the nurses decided was appropriate to ask. It's quite a big range. I think we have between like 7 millimetres and 48 millimetre tumours, but only I think 4 of them were above 20 millimetres. So it's still a cohort that we're able to diagnose a lot of stage 1 cancers, which is pretty exciting.
So why look for an alternative to mammograms in the first place? Well, part of it is that not all women take up the offer of free screening. Jessica's team has conducted a survey, and as we mentioned earlier, there could be a couple of reasons. One is comfort or lack thereof of the procedure, although Jessica doesn't think that puts too many women off.
I don't think people are as concerned about the breast compression. I think most women are pretty hardy and they'd go in for breast cancer screening, even if it's a little bit uncomfortable.
And there's not much that would prevent this group of friends from getting their mammograms.
Well, we all have them, don't we?
I don't find it a big deal at all.
That whole thing, I don't know who it is that talks about your breast being stuck in a garage door, for example. It is just so detrimental to helping women go and do something about it. That really, really frustrates me. I think women do a disservice to other women by speaking like that about it.
I don't think anyone finds it pleasant, though. I think a lot of people find them uncomfortable.
I find it a lot easier now than I used to. It used to really hurt. I don't find it as painful anymore.
But Jessica believes there are women who've avoided mammograms altogether.
It's often like a privacy reason as well, or just, not liking the kind of invasiveness of having it clamped down and things like that. So yeah, I know people who've been adverse to getting mammography and who've contracted breast cancer. So I think something like this where, it's non-invasive, one woman even fell asleep when we were doing one of the ergonomic trials. So it's obviously not too uncomfortable and, it would kind of improve those outcomes for women.
You could market it as a secondary use as a relaxation device.
Yeah, potentially. Well, it definitely seems a lot nicer than what happens currently.
And then the other reason we mentioned earlier on,
the access is a big one.
So some women simply haven't been able to get their mammograms in time.
I know over COVID they got so behind with the breast screening, and I know mine came up just after COVID, and I knew I needed to get it done. But did anyone contact me? No. So I ended up phoning and saying, hey, look, I'm due mine.
In May 2023, a damning national report showed about 50,000 women missed out on breast screening in the previous 2 years because of COVID disruptions. The report found the delay could cause problems for years, and it made 26 recommendations for change. In response, Te Whatu Ora announced a new national screening register and a breast screening action plan.
After COVID, there's such a big backlog and people's cancer screenings are getting delayed so much, and some of those women have been found recently to have worse outcomes because of delayed screening.
Jessica's hopeful that this machine could make a difference. Because it's fully automated, that means it doesn't require an operator. So it could make it easier to test more women.
So I guess it's just being able to increase the capacity as well. Because it doesn't require anyone skilled to facilitate or interpret the results, then it could increase the amount of women that we can screen, basically. And because it's portable and you can take the machine to them, or you can have it in GPs, it's just one less place for people to have to go. They go in for a regular GP checkup and they can just pop on the machine and have their screen if they haven't had it for a while.
And if the screening process is an easy one, that means women are likely to test more often. So that means more data can be collected, building a picture and history of each woman's breasts.
We're hoping that with more data we can kind of develop like a model of how each individual's breast vibrates, so we can kind of personalise diagnosis. So if you started screening early and if you were screening regularly, then we can use that data to not only, infer a diagnostic from one screen, but also look at all your past screens to see how that vibration is changing. And obviously you'd need to take into account things like pregnancy, etc. But you could kind of use that to, if there was suddenly someone's breast was getting stiffer, which usually breasts get less stiff over time, that would be a cause for concern and could indicate, potentially a large tumour growing amongst the whole breast, as opposed to our kind of like segmentation that we're doing at the moment. So those things are things that will develop as we get more data and as we do more clinical trials.
ultimately she'd like to see women in all parts of the country have early and ready access to this kind of device.
So we want it to be a pre-screening tool because we want it to increase access to screening. So this could be used to kind of provide pop-up screening to rural communities or communities that have, they might not be able to travel to the main centres to get a mammogram. It can kind of be used every other year between mammograms for people. All women under 45 will be able to use it because it's got no radiation. So it's safe for women of all ages, and it can kind of increase access to that first level of screening.
That idea of women of all ages is an important one too, because there's real concern about women who are under the age of 45 and who may have breast cancer, but they're too young to qualify for a free mammogram.
Well, I worry about all those vulnerable women in their 40s that don't have mammograms and then get to 50 and then find out that they've had it brewing for some time, and, it's not an easy journey then.
And then I wonder what happens when you've had breast cancer and then you've got daughters. Yeah, you don't really want to wait.
I always remember a friend of mine, she was sitting around the dinner table with her sister-in-law, and it came up, that debate, or should you have a mammogram between 40 and 45? And I said, yes, I think you should. And then that picked up her breast cancer that much earlier.
But as with a lot of health checks, it comes down to cost. Mammograms are expensive and MRIs even more so. Jessica's hoping to get the cost of this device down to between $20 and $50 per screening.
Once we've kind of optimised some of the frequencies and stuff, it'll be, very short and very easy. And obviously, like I said, we can kind of automate the whole process. So you might be able to have multiple machines with kind of just, barriers up between, and people kind of facilitating their own screening, because obviously all the actuator moving up and everything is all automated.
Because it turns out that getting bad news at that first or second mammogram is not that uncommon.
So I think a lot of people think that women under 45, that there's a low incidence of cancer, but some of the kind of analysis that I've done has found that when people reach 45, they're diagnosed with really large tumours. So there's a big spike of the number of large tumours diagnosed at age 45, which basically means that because there's no screening available to younger women, their tumours are kind of being left to grow unchecked, and then they reach 45 and have the opportunity to be diagnosed. So if they're being diagnosed with tumours, over 20, over 50 millimetres at 45, then they obviously had them when they were younger. So I think that people think that the issue of cancer in younger women is a lot lower just because we're not screening, so we don't know that incidence is actually occurring when they're younger. So a technology like ours could kind of, improve diagnosis from a younger age so that younger women aren't being diagnosed with larger tumours and having worse outcomes.
I can be blunter. About 10 to 12% of all breast cancer is diagnosed in women under 45 or under 40. Everybody counts differently. That's 1 in 10. Do they not count?
Now that's Jeff Chase jumping in there. Distinguished Professor Jeff Chase from the university's Mechanical Engineering Department. And we've actually met him on Our Changing World before. That was back in October 2021 when we looked at another biomedical device designed to simplify and speed up emergency tracheostomies. So he has an eye for the bigger picture and a lot of ideas for practical devices that could be used in our health system. We'll get to that shortly. For the moment, the breast screening tool might just be his favourite.
This is one of my very best ideas. I would really like to see it go. It is really difficult to talk to funders and always hear, yet another round of reasons why, is the market not big enough, or is it really a serious problem, phrased in some other thing. It's a huge problem. It's a huge cost. It's a huge issue.
So whilst his PhD is in civil engineering and control systems, over the years he's done a lot of research with health clinicians here in Christchurch.
Talking about different technologies and the way you can leverage interesting or unique patient situations to have potential impact. And breast cancer came up.
So as we've heard, this technology is about using the vibrations to work out what's under the surface of the breast. But to do that, Jeff says you don't need full volume imaging.
So full volume imaging, X-ray will give you that. It looks all the way through. MRI will give you that. If you show it some motion, it will tell you the full volume of what's going on throughout the breast at different depths. Ultrasounds will, with a measurable chunk of noise, but you don't necessarily need that.
Instead, by applying principles of earthquake engineering and digital imaging to the problem, it's resulted in this device, which Jeff likes to call the DIAT.
DIAT is digital imaging elastotomography. So, in essence, elastotomography is looking at the elastic properties of something and estimating throughout its volume, or at least an estimate of what's underneath. And this is digital imaging based, so we use digital cameras to measure that surface motion. So it's just digital imaging based elastotomography, not a diet. You can all keep eating snacks, it's all fine. But it's just an easy acronym because I can't even say digital imaging based elastotomography one time fast and get it right. So
you almost pulled it off there.
Yeah, almost. In essence, you're then removing a lot of the cost of the machine because it's digital imaging and that all gets cheaper every year. Some computer processing, that's all quite cheap. It's portable, so we wheeled it out. Not the prettiest thing in the world in its current prototype, but it's portable. And finally, it doesn't need then an expensive room. We could do it in here or in the lab there. So no expensive premises, no expensive people, no dangerous radiation, lower cost device overall. So this is attacking all those elements that I spoke of. So you want to attack the cost with a lower cost piece of equipment that doesn't require expensive people and premises. You'd like to be equally effective, and then you'd like to get rid of the x-rays, which limit screening to a certain age group and unfortunately low compliance.
So we've talked before about biomedical solutions. Is it becoming a bit of a habit of yours?
I like biomedical solutions because you're impacting people. You can read any chunk of the news. Healthcare, the cost of healthcare is rising faster, and more of the cost is then put off onto people. This creates inequity of access or ability to access the best care. So I like problems that use technology to create a low cost or lower cost solution, or even save money, and provide that equity and somehow return that to the system. So for women, a lot of women who are at risk of breast cancer, there's the BRCA1 and BRCA2, as they're called, breast cancer genes that are known, but there are other genes. If you ask around, not too many women, you'll come across somebody who is either part of a family or knows someone who's part of a family where some astronomical number of women in the immediate line of the family will have had breast cancer, and everybody else is nervous. Why not try to create a solution that affects that, brings down the total cost, allows you to rise to meet compliance? These are sort of multiple positive benefits that can hopefully spin off, and that's, I think, where, if you want my personal statement on where research investment should be made in this country, then we should be looking for solutions that have multiple positive flow-ons. Health research is nice. It's great to understand more about genomes and phenomes, and it's great to understand a bit more about disease processes, but it's not trying to do something for a large number of people on the street today who have a problem here today and now.
The next step is to fundraise for a larger clinical trial. The team will also build another ergonomic prototype and make adjustments to the cameras and the actuator. The device will still be very much a pre-screening tool, and any positive results it finds will be followed up with mammography or an MRI.
All the diagnostics have like a hierarchy, right? So if you go into and get a mammogram, usually you're going to be referred on to either another mammogram for more views, or an ultrasound, or if maybe you have dense breast tissue, might be an MRI, and then onto a biopsy and before you're actually diagnosed. So it's going to sit in that hierarchy of testing.
But these women are interested to hear of any new tool in the battle against breast cancer.
Like my daughters, late teens, early 20s, you do hear of breast cancer at 26. It would be good peace of mind for them to be able to access something like that if they've had a mother that has had breast cancer.
If you found that it was affordable, people would do it.
Most people really, will have some form of body hang-up. If you're worried about your tummy, you don't want to be seen naked and somebody looking at you or touching you or whatever, then it eliminates all of that.
Thanks, Katy. Katy spoke to Dr. Jessica Fitzjohn and Distinguished Professor Jeff Chase, both from the Mechanical Engineering Department at the University of Canterbury, Te Whare Wāngana o Waitaha. She also spoke to a group of Christchurch friends with some experience of breast cancer. This episode was produced by Katy Gosset and engineered by Alex Harmer. Ko Tim Wakin te tumu kaihotu o nā kōnei iparangi me nā hōtaka ki te reo irirangi o Aotearoa. Tim Wakin is the executive producer of podcasts and series at RNZ. Kia whaia I te au hurihanga I tētahi taupanga pai ake kia koe. Follow Our Changing World on your favourite podcast app to never miss an episode. Or subscribe to the RNZ podcast channel on YouTube and look for the Our Changing World playlist. Our website is at rnz.co.nz/ourchangingworld, where you can sign up to our monthly newsletter. And you can find us on Twitter or Facebook at RNZ Science. Looking for your next podcast listen? Well, check out the extensive range on offer at RNZ by clicking on the podcast and series tab on the website. New podcasts are coming out all the time on such a huge range of topics. There's something for everyone. Tēnā koe I whakarongo mai. Thanks so much for listening. I'm Claire Kincannon. Have a great week. Kia pai tō wiki.